Welcome to our deep learning course for semantic segmentation with Python and PyTorch. Are you ready to take your understanding of deep learning to the next level and learn how to apply it to real-world problems? This course is designed to give you hands-on experience using Python and PyTorch to build, train, and test deep learning models for semantic segmentation applications. Deep learning is one of the most effective approaches to semantic segmentation, which involves training a neural network to learn complex relationships between pixels and able to learn rich feature representations. Semantic segmentation is a computer vision task that involves classifying every pixel in an image. The aim of semantic segmentation is to assign a semantic label to each object in an image. If you are a deep learning enthusiast, you must learn the semantic segmentation because of its wide range potential applications in real life. Semantic segmentation can be used in autonomous vehicles to help the vehicle understand and interpret its environment, identify different objects within it. The vehicle uses semantic segmentation to identify and locate objects such as other vehicles, pedestrians, bicycles, and traffic signs in the scene. This information is then used to plan a safe and efficient path for the vehicle to follow. Semantic segmentation can be used in medical imaging to help physicians and radiologists. For example, tumor segmentation. Semantic segmentation can be used in food nutrient intake analysis to help with the monitoring and tracking of an individual diet and nutrition. Semantic segmentation can be used in satellite image analysis, such as buildings, roads, water bodies, and vegetation. Semantic segmentation can be used in image search engines to help users find and retrieve specific images. The drone uses semantic segmentation to identify and locate objects. The robot uses semantic segmentation to identify and locate objects such as furniture, people, and other obstacles in the environment. Semantic segmentation can also be used in augmented reality entertainment applications. Semantic segmentation can be used in human-machine interaction. Semantic segmentation follows the encoder-decoder architecture. The encoder increases the number of channels and downsample the image, while decoder upsamples the feature maps and decrease the number of channels. You will be able to implement various segmentation models with the combination of different state-of-the-art encoder and decoder architectures. For example, you can use ResNet encoder with different decoders such as UNet, PSPNet, DeepLab, etc. And similarly, you can define other combinations of the encoders and decoders. You will perform the data augmentation to produce transformed and altered version of the original images to increase the size and the diversity of the training dataset that can improve the performance of the deep learning model. To evaluate the performance of semantic segmentation model, you will use common segmentation matrix. You will also be able to calculate the intersection over union for each class in your dataset. You will implement the complete pipeline from data loading to model optimization, training, testing, and visualization of the segmentation results with the help of Python and PyTorch. This course is designed for students and researchers who want to become machine learning engineers, deep learning engineers, data scientists, computer vision engineers, to learn how to use PyTorch to build and train deep learning models for semantic segmentation. I will also provide you all the Python code so that you can practice and get started immediately. By the end of this course, you will have the knowledge and skills you need to start applying deep learning to semantic segmentation problems in your own work or research. This course is a perfect way to take your understanding of deep learning to the next level. So what are you waiting for? Enroll it now and let's get started on this exciting journey of deep learning for semantic segmentation with Python and PyTorch. See you in the first lesson.